Hello everyone, my name is Olena. I am a developer advocate working at Ivan, where we help engineers to deal with all the complexities and headaches of database infrastructure. At Ivan, we also support and contribute a lot to open source projects, including Apache Kafka. And I must say that Apache Kafka is one of our favorites, or it is definitely my favorite. Apache Kafka offers a very powerful and flexible way to transport the messages across multiple systems. It is a fast and flexible platform sorry. So, I'm very sorry. But this platform has a reputation of being somewhat complex. And I believe this reputation isn't completely fair because Apache Kafka is actually based on a set of simple and straightforward principles. And some complexity comes from misusing or misunderstanding these principles. That's why today, during this session, I wanted to look at one of the areas of Apache Kafka, which is very important, but often brings confusion both to engineers who just started using the platform and those who already have some experience. And based on the title of this talk, you can guess that I'm talking about partitioning and data balancing. So what is partitioning? In Apache Kafka, we often talk about topics, and data into the topics is pushed by some producers and then later pulled by some consumers. But the thing is, the topic itself is actually an abstract term because physically on the disks, the data is stored in partitions. So partitioning is a mechanism to distribute data from the topic across multiple brokers in the cluster. It is also, very importantly, a way to parallelize production of the messages which go into the system and then consumption of those messages. So it is a key for the horizontal scaling of your system, of the platform. And it's a very, very powerful mechanism. However, like with everything in life, nothing comes for free. And distributed systems, by design, they are complex. And many things can go wrong and will go wrong. Luckily, with Apache Kafka, we don't have to worry much about durable messaging or distributed concurrent transactions. We can also delegate the high availability questions, security, and scaling to data infrastructure providers, probably like Ivan. But to get the full flexibility of the system and the full power, you still need to put in some work and customize the platform using the provided abstractions. And one of the most important decisions you will have to make when working with Apache Kafka is how to partition the data. So today, you will learn during the session how exactly partitioning works in Apache Kafka, how default partitioner decides where to send the data, how many partitions actually you need per your topic based on your scenario, and what awful nasty things happen to the system in case you did the data distribution in a bad way, and how to proactively prevent that. And finally, if the advice didn't help or you just ignored it, what to do if you have skewed data distribution across the cluster. When we are talking about architecture and performance, it's quite important to define the metrics we are using to measure our performance. In distributed systems especially, we often have to find trade-offs. You can't really have it all, so often we will have to look for having the maximum value, but still paying the least price in complexities and costs. Three different metrics we will be mentioning today during this talk are throughput, which is amount of messages which goes through the system in a given amount of time. The higher, the better. Latency, how much time it takes to process every message or a single message. The lower, the better. Those two, throughput and latency, they have a somewhat complex relationship. They are interconnected, and by modifying one, often we will influence the other one, and not always in the good way. And the third metric, which is important, and we will be mentioning that several times, is the lag. This is the difference between the offset of the last produced message and the last consumer's committed message. In other words, how far our consumer behind the producer. And we measure that in the difference between the offsets of those messages. If you are still puzzled about these metrics, I also have a very simple bus analogy where the passengers are records in the system. So throughput is how many people we can fit into the bus. Latency is how much time it takes for a passenger to reach the final destination, including not only the time spent in the bus, but also the time which is spent on the bus station and waiting for the bus. And finally, the lag is how far the furthest passenger behind the front of the group. So keeping these metrics in mind, let's start with a question. How many partitions you actually need for your topic? And you will have to define number of partitions when you create a topic. And because not always you can change that number later in time, it's quite important to carefully consider and determine how many partitions you need and what is the most optimal number based on the information you have at that moment about the data and the system. This is not the case where you want to get inspired from your friend who also uses Apache Kafka and he says, oh, I'm having 30 partitions, and you're like, good, I'll use that number as well. Or maybe like LinkedIn and they wrote an article and they're using that number of partitions, like, no, you shouldn't really do it. And to explain why, let's look at two extremes, having too few partitions and having too many partitions. Having too few partitions will negatively result in performance and scalability of your system, because having too few partitions will limit the overall throughput of the data going through your system. It's like having 2 traffic lanes instead of 5. The less traffic lanes you have, the slower will be the movement of the cars. And all the traffic examples are pretty cool here in Atlanta. The second thing is that you need to remember that the number of consumers in the consumer group is limited by the number of partitions you have in your system. So if you have more consumer instances than you have partitions, those instances will be idle, they won't do anything. Like Danica yesterday said, they will be starving. So because of these things, there is a common recommendation. When you create a topic, set the number of partitions somewhat higher to plan for the future. And indeed, it's a really good recommendation. However, it has a danger that some people set this number significantly higher just in case. And sadly, this brings a totally different set of issues. First of all the admin operations will take longer. And actually, we have seen it, I have seen it on some of the customers we have. They had too many partitions for no good reason. And then the issue was that all the admin operations were taking some ages. Because for every partition, you also have a replica. So you can't really blindly increase the number of partitions. And Also, when you have more partitions, you add more consumers. But more consumer instances also means that probability of a consumer's reassignments increases. So usually a consumer is exclusively assigned to one or more partitions. And if something happens with those consumers, then we have the reassignment process, and this takes time. And of course, this is an operation which you want to avoid. So too many partitions don't come for free, but too few is also bad. So where is this golden middle? My advice would be to start with the end in mind. And it's not a philosophical phrase. It's just when you plan how many partitions you want to have, think how the data will be consumed by your application and what is the throughput of your consumers. Measure the speed with which you can process a bunch of messages to see what is acceptable load on those consumers and how many of them you need to process the data in parallel. For example, if you targeted read capacity is 1 gigabyte per second, but your consumer can process 100 megabytes per second, then you need at least to have 10 consumers, and this means 10 partitions. And this would give you an idea for the minimal number of partitions you need to have in the system. Set this number somewhat higher, planning for the future. If in doubt, also select higher number of partitions rather than lower, but don't go for extremes. So, okay, so you put some effort into setting the number of partitions, you decided on that, but you also wonder, like, no one of us can predict the future. I think last 10 years just showed how much we can't really predict it. So can you change that number later? And the answer is sadly not always. So you cannot decrease the number of partitions. So if you selected 10, you can go to 5. However, you can increase the number of partitions. Whether increasing is a good idea or the idea which will bring you lots of issues later depends how you were distributing the data before this and if you actually care about the ordering of the messages and you are using the keys. And if you are using the keys, changing the number of partitions is not a piece of cake, and we'll see later why. But for now, let's move on and see how partitioning actually happens in Apache Kafka. And we will start with the default partitioner. There are 3 main things default partitioner will look for when deciding where to send the data. Here I have on the, is it right? I have on the right, I have the producer with the data, and on the left, I'm really bad with left and right, we have the 3 partitions distributed across 3 different brokers. And the first thing the producer will look for if you explicitly assign the number of partitions where the data should go. Usually, you wouldn't really want to do that. But if you have to, you can. I would call it micromanagement and would rather discourage this type of functionality. However, in some cases where you have some complex scenarios, where you have some edge cases, you might want to do that. If you didn't provide the number explicitly, then the partitioner will look for the key. If you have the key, it will take the hash of the key, transform that into a number, and then to take the modulo on the number of partitions. And then it will get a partition where it will send the data. And the idea behind this mechanism is that we always want the key to correspond with exactly same partition. And this will help us guarantee the ordering of the records when we consume the data later. So in some cases, the data which is produced, that ordering, you want to maintain when the data is consumed. However, another challenge with distributed system that we write the data over here, on this partition, over there, on that server, and so on. So later in time, it's pretty tricky to say which actually message was first and which second. unless you use same partition and then you use the same log file and you write item one after another, because this is how the log files work, and you guarantee the ordering. However, an interesting thing, think what happens if we decide to change the number of partitions later in this formula. So we are increasing the number, say you had, I don't know, 10 partitions and you decided to go for 15. The distribution of the data across partitions will change. And if you relied on the ordering, on the fact that you write the same data with the same key to the same partition, once you change that number, the dedicated partitions will change and your ordering will be affected. That's why changing number of partitions, if you are using the keys, is not always an easy process. We'll come back later what you can do here, but for now let's move to the third scenario. What if you didn't provide the number explicitly and neither you have a key? In this case, we rely on the built-in mechanism of data distribution for Apache Kafka. And in the old days, we were using round-robin partitioning. And round-robin was iterating over partitions and spreading the items one by one to achieve the even data distribution. Here, it's important to note that round-robin was not really sending those items immediately. That would be such an overkill. No, it was keeping that data in the buffer locally on the disk, then accumulating and sending those batches to the partitions. And in this way, it was achieved a nice and even data distribution. However, there are a couple of issues with this approach. And one of those, it's not exceptionally optimal. So here, for example, we are going to send two items in a batch to the partition. We could have sent actually all 6 items within one batch. And smarter batch sizing actually affects significantly the load on the network and on the broker, because sometimes you actually want to combine more items together and send less of those batches to the server. And this is exactly what sticky partitioning is doing. Sticky partitioning will select a partition and then continue assigning items to that to a batch locally till one of 2 conditions happen. Either we reach the time limit allowed for that operation, or we reach the size limit. Once that happens, the batch will be sent to the cluster, to that partition. Then the sticky partitioning will select the next partition and do that operation again and again. And this, the idea behind this is that with the time, we still evenly distribute the data across those partitions. And the advantage based on the benchmarks is significant reduction in the latency. So the latency reduction is around 50% comparing to the round-robin, and there is also CPU utilization reduction in 15%. So it's quite impressive. However, again, like with everything nice in life, we now need to take care of some new scenarios and new edge cases where the even distribution of data turns out to be not as even as we could have thought. We'll see that later, but for now, let's look at the properties which I mentioned, the limit by time. This is linger MS. By default, it is 0. You want to increase that number so that you allow accumulation of the data and sending it before you send to the cluster. And the batch size is also set to this value, and you might want to play it according to your scenario. Cool. So to summarize, the default partitioner will look for exact number if you provide it, where you want to send the data. If you didn't provide it, it will check for the key, and if you don't have the key, it will use the default partitioning strategy, which is sticky partitioning, if you are using the latest version of Apache Kafka. If you don't like any of those options, you're picky. But that's fine too, because you can actually create a custom partitioner and implement your custom logic. And here it's very useful when you can't really use the key for deciding where the data should go, but you want to rely either on different property or maybe combination of the properties in your data. So in this case, you can use the custom partitioner. But now that we talked about the alternatives that we have, we need to find a good motivation to put some effort into finding a good strategy. And nothing gives better motivation than seeing what things can go really, really wrong if your data is badly distributed, if you have unbalanced partitions. For example, situation like this. We have a topic with 6 partitions, and majority of data for some reason went into the first partition. Sadly, this situation isn't really rare, and we see it quite frequently, and the reasons are really crazy. But let's see what actually happens to the system, starting with the producers. And funnily enough, even though the producers are the ones who distribute the data, producers are it's very difficult to spot the issue on the producer side. There are certain things which happen wrong on the producer. For example, if your producer sends the data all the time into the same partition and then waits for acknowledgement, what happens that producer might have to accumulate data locally and then have issues with the storage and performance. But in majority of the cases, producer is the least victim of this situation, especially if we talk about brokers and consumers. And to understand the issue with the brokers, let's talk how the data is actually stored on the brokers. On the brokers, we have different files on the disk storage. And each file corresponds to a partition. And each file contains different files, each folder corresponds to different partition, and each folder will contain different files, which are segments of the partition. And those files will have records. So when we send the data to the broker, we are writing on the disk. This is a load on the file system. And if we have one of those hot partitions with a lot of data, that means that we will have a high load on the file storage of the broker. And our brokers, they are pretty tough, so they can handle some of that load. But once you have not one hot partition, but you have more on some issues, the broker becomes slower, writing the data slower, worsening all the performance metrics which we have. And this affects not only our hot partitions, but sadly, it affects all the partitions and all the replicas which we have on that broker, which is totally not good. To fix this, you might rebalance the hot partitions across the broker, so no single broker will have to struggle because of those hot partitions, or at least like they have all evenly. But still, if your logic behind the data distribution is not really good, then it's only a workaround for some short time. But brokers are doing still fine comparing to what happens with consumers. So each consumer is exclusively assigned to one or more partition. And if we scale this relationship to the maximum, the consumer will be assigned taking care of one partition, like in the slide over here. And this means that if a partition gets significantly more data, then the consumer will have to use significantly more resources to process that data. you can't add more nodes. One-to-one is a maximum relationship. So solution you might want to use at this point of time is to scale vertically. And there is nothing bad about scaling vertically. Scaling vertically is actually a valid, good strategy. However, it has its limitations. First of all, we can't really scale to the infinity at some point of time. It won't make any more sense. And second, if you are using some orchestration tools, for example, if you're relying on Kubernetes, most probably you will use the same type of node for all of your consumer instances. But that would mean that you will have to use those huge nodes just because you have one hot partition. And you will know perfectly well that the rest of the consumers will be underutilizing that power. Which is sad, especially in the world where we care about energy consumption, so not really good. However, if it works, okay, it works, you will still have increased lag, but maybe that will be a sufficient solution for you. The worst comes if a consumer can't handle that load. If the consumer, for some reason, starts using too much memory, too much CPU, it will be killed with out-of-memory killer. Then a new consumer, the new node, starts fresh and eager to jump on that work, but that one is also killed with an exception because it tries to consume too much data. And it goes on, and this is just a disaster. So why exactly this happened, and more importantly, how we can prevent these issues? And the first reason is that we have an issue with the key. The key which we selected to distribute the data wasn't the perfect one. Let me give you an example. Imagine you own an online shop and you are selling cheese. And you rely on Apache Kafka topic for the purchase flow. And to keep the order of the messages correct and also to distribute the data evenly, you decided that you will be using customer ID as the key. And it all started well enough. However, with time, you realized that not all customers are even. Majority will do the purchase once a week, but there are certain customers which are cheese addicts and they will do purchase several times a day. And they contribute to creation of hot topics by producing way more records into the system. What could have helped if when selecting the key, you would select a key which doesn't have a potential to be overly used. For example, instead of customer ID, you could have created some kind of purchase flow ID. So it will be shorter. So every time the customer starts the purchase, puts, for example, something into the basket, then you start the purchase flow and you create some ID, and then the items, the records within that purchase, they must be in order because it's important that first the customer adds something, then he pays for the purchase, and then we deliver the parcel. So we don't want to mess up that ordering. But the number of items within that flow is limited by the design. So we don't have this kind of overusing of the key. So when you're looking for a good key, look for values with highest cardinality or highest variety which you can have, but which still can help you with the critical ordering for your system. Great, so this is when you use a key. But sometimes you don't use a key. You rely on the default partitioning mechanism by Apache Kafka, and you expect that everything will be nice and beautiful and even, and it's not. And there are a couple of reasons for this. First of all, your system wasn't ready to the uneven distribution of data over time. Let's look at this graph where we see the customer activity distribution over time. In retail, it's pretty frequent to see that customers are more active during the middle of the day and they are less active during the night. So if we are using the default values for sticky partitioning, then it means that during the middle of the day, we start sending a bunch of messages, a bunch of batches into the system, and this will overload the system. So normally, what strategy you will take? You will increase a bit the linger MS to allow that batch to accumulate, and you increase the batch size. This is a very commonly used strategy. You don't want to have linger MS too big, because otherwise during the night it will take a long time for the batch to accumulate. So you keep also linger MS pretty small. And this is a great approach. However, it has a tiny risk which can result in huge partition. Some people, with the purpose, innocent purpose to accommodate all possible scenarios, will set the batch size really, really, really high. Like, yeah, during the day it will work, and during the night, linger MS will save us. But then what happens? We have unexpected data load. For example, our producer restarts and sends a bunch of messages into the system. And this will result with a lot of data going into a single partition, because it's less than batch size and it all fits. So this is a danger of kind of using some extreme values again. You should be very careful when using those. By the way, this wouldn't happen if you use the keys. It's not to say that you should use keys everywhere, no. But I mean, just to understand that this uneven distribution will not happen if you are relying on keys to distribute your data. And sticky partitioning, if used right, is very, very powerful mechanism. However, there is one more issue you need to be aware of, which was improved recently. But in case you are still using older version of Apache Kafka, or in case you are not aware that you need to change some of the properties, I wanted to share with you the scenario. And this situation happens if one of the brokers you have in the system is significantly slower than others. Let's imagine it's our first broker over there. And for some reason, maybe too many hot partitions, maybe some other things bother that broker, but it's slower. And when we distribute the data across the partitions with sticky partitioning, we just send the data. But what happens then? We need to get acknowledgement from the broker that it is ready to accept more data. And you remember, our first broker is very slow. So we accumulate data, we selected that partition to send the data, we are waiting for acknowledgement from the broker, but we already accumulate the data. Data comes from the producer. And we continue accumulating, and we wait, and in the end, we accumulated there locally significantly more data than we initially wanted to send to the broker. And our broker replies, finally, yes, I am here, you can send me data, we send the data, but what it results in is that our poor, struggling broker receives significantly more data than it's supposed to get, making its poor life even more difficult. So this is kind of an avalanche effect, and it's really not good, and it was resulting with brokers heavily overloaded. Those brokers who actually need less data to survive. This issue was recognized and fixed in Apache Kafka 3.3. So now you have two properties which you can set. First one is to enable adaptive partitioning. This will allow the partitioner smartly approach the slower brokers. Partitioner will try to send more data to the faster brokers. So you can set that to true. You can also set the availability timeout. If you set it bigger than 0, then partitioner will wait for the time, and if the broker doesn't reply within that timeout, it will be assumed that the broker is not available. If it's set to 0, this setting is disabled. If you are still using old version of Apache Kafka, first of all, maybe it's time to update to the latest version. But if you can't, then you will have to play with Linger MS, but also remember that this will affect the latency. So you will probably also need to rebalance the hot partitions on a regular basis, so that no broker is significantly slower than others. Great. So another reason why you might have hot partitions is that you initially had small number of partitions and you decided to scale and you added more, but this helps, but it doesn't really, sometimes it doesn't really fix the issue. One more thing I wanted to mention is that when you're working with consumers, think also what is the fetch size you're using to bring the data from the cluster. Like with batch size for the producer, the fetch size bigger will allow to send bigger batches from the broker to the consumer and to save on the network load and on the consumer load. Of course, again, you don't want to use too big fetch size because this will bring to other issues and your consumer might have troubles processing all the messages it gets. You might also consider using compression. For example, if your bottleneck of the system is the messages which go through the broker, you might compress those messages before you send and then decompress. Of course, you will spend some computation power on the producer side and on the consumer side. You can play with the different algorithms because there are different algorithms which will compress with different efficiency and consuming different resources. Maybe you don't need to compress too much, but you will spend less resources. So it's all of this is like with cooking. Like when you put some salt into the dish, you should be careful to put too much, but also you don't want to put too little. So what will help you to stay proactive and to find issues sooner is monitoring and measurement. And a couple of ideas. There are plenty of things you actually might want to measure, but a couple of ideas, of course, consumer lag. This is a very important property to observe. Also, pay attention to under-replicated partitions. If you notice some partitions being under-replicated, most probably there is something going there with that partition. So you want to check it. Also, where the difference between latency, average latency, and maximum latency is too big, then you want also to pay closer attention there. But sometimes it's too late for a good advice. Sometimes you probably have either some hot partitions or you selected too few partitions and now brokers are suffering, consumers are desperate and your boss is very, very unhappy. So what exactly can you do in this case? And I wanted just to give you some ideas. This is a bit more, maybe deeper topic and a bit more complex, but I wanted just that you know and aware what overall options you might have. First of all, if for your topic you don't have keys, you can add more partitions. Especially if you have topic compaction or reasonable retention period, with the time, the data will be rebalanced. And with more partitions, you can add more consumers and the data consumption will be faster. If you use the keys, but if you only have a couple of those hot keys, not many, just several, then potentially you still can add more partitions. But remember what we were talking about, the ordering of the data? That becomes a bit tricky. And here you will need to use a custom producer and custom assigner to make sure that the data for those hot keys which you have goes to particular partition and then goes to particular consumer, and then also you don't ruin the ordering of the data. So this is probably not the easiest approach as well. The last approach you can take, the most dramatic, is to create a new topic with new partitioning rules, and then either to move the data from the old topic or maybe just to restart from the new topic. This is complex. You might also think it's an overkill. However, this will help you solve the issue for way longer time and with longer lasting results. And also, recreating a topic is useful not only to rebalance the records, but also you might want to know how to do it properly for disaster recovery, scaling up or down, changing the schema. In all those cases, you might want to create a new topic and start producing and consuming data from that topic. You need to be aware of offset translations for this case, so that when you move, for example, consumers, that consumers start from the moment, so they stop in the old topic, consuming data, and they start from the new topic, and that they start from the right time, and they don't consume records twice, or they don't miss the records. And actually, like, offset translation is a pretty complex thing to do. Some tools like Mirror Maker, they promise solution, but they are, let's say, they are problematic actually. And when you change the number of partitions, Mirror Maker is actually not the tool which will do that offset translation correctly. And what I wanted to leave you with is that it's admittedly very difficult to predict everything. And planning is very, very important. However, fully predicting the future is just impossible. So those attempts to kind of be ready for all the things which can go wrong and kind of prevent those issues might lead to the premature optimization, which is not really a good thing to overcomplicate the system. So my advice would be not to try to avoid all potential issues, but to be ready for the change when this change unavoidably comes. So I wanted to leave you with these key learnings. When you're calculating the number of partitions, think how the data will be consumed. Looking for the best key, find the values with highest cardinality, which will still help you to preserve the most critical ordering of the data, of the records. Keep the distribution of the data over time, observe and monitor, and be ready for the change. Finally, if you want to try Apache Kafka, you're looking for some reliable data infrastructure solution, try out Ivan.io. This is the company where I work. We offer management of the infrastructure for Apache Kafka. We also offer free credits, so you can try and play with Apache Kafka. You don't need to provide any credit cards or anything, so just experiment with it. We have also whole infrastructure with other tools and solutions. I also created a GitHub repository with some links to, for example, to Keeps, where the discussion is about why we need sticky partitioner, also like benchmarks and the rest, as well as other articles you might find useful on this topic. And finally, feel free to connect with me somewhere in the internet. Thank you very much, and I'm looking forward to your questions. Okay, I see a question over there. I don't think you can really like suggest an average because that average might not work for your system. I would say you can, I mean, like out of my head, like you can start, for example, with 6. But I would be really careful with like trying average because your system might be different. Think like what kind of like throughput you have, what kind of like consumer load you expect, and then you can decide because different systems will have totally different needs. I don't think you can really say like the best practice would be to look what your system needs. Because like, it's again, I wouldn't really copy from other systems because you actually, what's good for other system might be totally not good for you. So when, for example, someone was mentioning they have 30 partition, but there was like, they had too much, like I was recently just talking to a customer and they had 30 partitions. It's like 30 sounds kind of not that big number, but for their case, it was too much and then they had these issues with admin operations taking too long and they were like, we are suffering, all that stuff takes too long. And for that case, they could decrease it by 10, like have 10 partitions instead of 30. So I would say start with a reasonable number for your system. Don't go for too much.
Does Kafka integrate with Google Cloud in any way?
With which part of Google Cloud? You can integrate Apache Kafka with plenty of systems. So if you're using Kafka Connect, this is part of ecosystem of Apache Kafka, you can integrate with various different solutions because there are various different connectors, either to bring the data into Apache Kafka or to bring the data from Apache Kafka to those solutions. So it will depend what kind of like, what database, what system exactly you want to integrate it with. Do you know? Cloud Composer. I don't know about Cloud Composer. I would check one of the available connectors because I bet that you are not the only person who needs that, and there is a bunch of connectors for Apache Kafka to integrate with different, like bunch, and I'm saying like it's really big number, I don't know, like hundreds, like different solutions. So I think you also need to know, like, I think the Cloud Composer sounds not really as a data source. You need to think like granularly, like where exactly, is it like a database or something you want to bring the data from?
Yeah, so Cloud Composer is kind of like Apache Airflow. So we get our data from BigQuery and push it into.
I see. I think it's possible. I can't really. We can check later with you, like for the connectors, and see if there is already something existing there.
If you have a consumer that's is actually pulling from an existing topic, but you have to rekey for whatever reason it requires a rekey, are you still restricted by the partitions you first created for the original topic, or can you generate new partitions based upon your new key?
So you can change the key, but you cannot do it within the existing topic. So, I mean, depends why you need the keys. A lot of people will use keys because they want to maintain the ordering of the records for that key. But once you change the strategy, then you have kind of a mess of the data with different key. If that's your goal, you can totally do it. I mean, like, no one stops you. It's just like what you will get from that. So I wouldn't do it. I would say what you are suggesting, more like you need a new topic with new partitioning strategy so that you kind of can make sense what is happening there. Yeah. Oh, sorry. Yes. Mm-hmm. So the question is about the batch sizes, and especially when we have big Avro messages and what kind of recommendations we have on that. So one thing which I see that people discuss is that if the data comes into the system and you notice that the data structure is either too big or too complex, maybe, just maybe, it makes sense to have two topics instead of one. because then you actually like aim for simplicity instead of trying to put everything together. So I would first consider that, because if you have something super complex, maybe during the system design you can kind of like simplify that. And then for the batch sizes, so definitely your batch size should make sure that you have enough space, depending on like the record size, and then you should probably make sure that enough records go through the system. Again, will be the question how your consumers also process the data. And how like producers produce, like, can you have bigger batch sizes? I mean, like on consumer side, you will need to change the fetch size as well for that. But you need them to accommodate if you really send huge amount. I mean, like you can send technically anything through Apache Kafka. It doesn't really care. It's just the question is, does it really make sense to have a really big message? And I would say you should be careful to send really big blocks of data, like big records. Yes. Mm-hmm.
So it'll look like the throughput is really high, but when you get to the end, there'll be just a few partitions that, like you said, are holding most of the
Yes.
throughput really, really drops. So like when you start.
I would look, is there a consistency that constantly the same partitions are taking longer? You can also check. So I think it's also like you can use some even scripts to see if, for example, do you rely, I'm sorry, I should have repeated the question. I'm very sorry. The question was, is that in the system, the movement of the data, the throughput, there is like a high load of the data, but then at the end, always the load on some partitions is higher, but on the rest is lower. So it's very similar to the situation with hot partitions. And where do we start looking for problem? And first of all, if you use the key, then I would use some script to analyze, do we have any data which goes with, like, is any of the keys is hotter than others? It's like, there is like the balance. Maybe you have one key which has like, you don't use the keys. If you don't use the keys, do you use a sticky partitioner? You need to check that. I mean, I'm actually pretty sure that you are using the sticky partition if the default one. Then also the data distribution over time, and also like if you have any unexpected peaks in the data, I would check that as well. So because look at the size of the partitions. And also that the consumers, maybe the issue actually on the side on the consumer. So I would look, is there like some kind of tendency of the same consumer to suffer or the same partitions to be bigger? Yeah, I would start there and then see, and then go try to figure out based on that. Yes. The linger mess question about tweaking. So linger mess, it's more or less when sticky partitioner will start accumulating data. If the defaults are as they are for sticky partitioners, that we actually don't really wait for many data to come. We will just be sending that to the cluster. But then actually the batch size won't be really big. So you might want to increase the linger MS, so you increase the time during which you accumulate the data and put it into that box that you then will be sending to the broker. And with this, you have less load on the network and less load on the broker, because like you will have to process just less messages at once. That's why we don't really send one item, like item after item to the broker. So like everyone says, like it's all about streaming of the data. No, it's like we use batching as well with Kafka because it's more efficient. So linger mess allows us to do that, but you shouldn't set it very high. Be very careful. If you set it very high, then during the low activity times, your customers will be, or like whatever is using the system will be just blocked, and this is also not good. Any more interesting questions? Any more uninteresting questions? Yes.
Besides creating a persistent store, is there a way to guarantee ordering? Kafka always says there's no guarantee of ordering. What's the best form of ordering?
Wait a second. it's not true. It's not like Kafka says we don't guarantee the ordering. I think like in a distributed system, ordering is difficult. However, when you imagine, and we were looking at the brokers and how the data is stored there, so when we look deeper and deeper and deeper, the data is stored in those log files. And are you familiar with the log structure? So in the logs, like we just write item after item. So we always append at the end. And that's where you can say, if the item was written here and then the next item is this one, then definitely the ordering of those items is exactly how it comes from the producer. Does it make sense?
It does, but if they're distributed, you can't guarantee which. So I guess the issue is it coming into the topic as they come in. There's no order as the producer's putting it onto the topic. Consumers just going to pick up whatever is available.
And the question is that how do we guarantee is if the consumers will pick up what is available. But that's actually why the maximum relationship between consumers and producers is one-to-one. So one consumer is exclusively assigned to one or more partitions. So one partition, so when we are looking at the size from the consumers and the partitions, it's not like several consumers can read the data from a partition. No. One consumer will be always reading from the same partition. So there will be no mixture between those. That's why you are sure that the data from the partition, it will be pushed by the producer, it will go to the log into the same partition, it will be written first item, second item, third item. And then one consumer, not several, they will not be mixing the data, it's only one consumer which will be written from that particular partition. And it will take first item, second item, third item. And that's how we guarantee it. Does this make sense? Okay. So many. Oh, yes. Wait, could you repeat? I can't hear very well. Uh-huh. Yes. Okay. So the question is, and I will repeat and you will tell me if I'm correct, is that if we have to recreate the topic, so that last thing I was showing, like the most dramatic thing you can ever do is like recreate the topic. And if it's complex, if it sounds as complex as this, or it's actually a piece of cake. This is the question, right? It's not a piece of cake. There are plenty of things to keep in mind, but it's also not impossible. So it will actually, like there are different things. There is no common, let's say, there are so many varieties of how you can do it, depending on what constraints you have in your system. So technically, you can do it in a very simple way. But like, for example, is when you recreate the topic, so you were consuming from the old topic and then you created a new one and you start consuming from the new one. Is it fine that you will consume several messages twice, like from the old, when you are shifting from the old topic to the new one? Is it fine for your system or not? And this will be a big question. If it's fine, then technically things are easier. This is a bit complex topic, but I can share actually some materials for that. We're going actually to do at Kafka Summit a talk exactly on that and provide the algorithm how you can do it. So I have actually like more deep stuff. But let's say, so the difficult part, the most difficult thing is actually to keep this offset translation. So offset in the topic is like the message in every partition, we kind of we put the numbers on every message. And then like when you switch from one partition to another, the distribution of data changes. So it's not like here the offset of the message consumer was reading was number 5, but here it can be, I don't know, like 0 or something else. So you need really some system which will remember and know how to shift. And this is the complex part. And then also the question is, like, do you need to make the sharp cut? Like, you can technically switch off, like stop the world, switch off producers, put them to the new topic, finish consuming all the messages. So there will be delays, but you finish consuming all the messages from the old topic, and then you switch the consumers to the new topic. This kind of easy if you're fine with kind of delay during this process. Totally. Like on the other hand, this is difficult if you need to do the rollbacks. So I mean, like there is no particular easy situation. Like if you want to roll back, this will be really, really hard. If you need to roll back, maybe you want to replicate the data. So you need some kind of data pump. So you have the old topic, and you start bringing the data into the new topic. So you're producing to the old topic, and you're consuming from the old topic. But you, at the same time, you replicate the data according to the new rules to the new topic. And then at some point of time, you switch the consumers. You can do the dry runs. You can kind of test if it all works, but you switch, like you have two systems in parallel. And then if everything is good, you switch also producers. There are more complexity because now you have this middle computation thing which should kind of reduce the messaging. Here there are some pros, but also there are some cons. I can actually take for another hour about that because it's like super cool. So, but I can kind of even like, we can talk, I have some notes from the next talk for Apache Kafka Summit, and this is very, very cool. Yeah, any more questions? If not, thank you so much.